Welcome back, dear students. So we are doing linear differential equation, right? So today also we will continue our series on linear differential equation. Okay, so we have done two questions as of now, and one question I gave you as homework, isn't it? So today I'm taking my third problem for the day. Okay, so third problem for linear differential equation, I'm sorry, right? So all of you know that general form of a different linear differential equation is dy by dx is equals to, I'm sorry, plus py is equals to how much? Q, where this p and q are either constant or function of x, isn't it? So let me represent this in this way. Okay, so I can write this from here, dy by dx. Okay, so if you bring it out here, it becomes minus 2y, isn't it? So instead of writing minus 2y, I'm going to write this as minus 2y. Okay, this much is also fine. So this is equals to cos x, cos 3x, right? So basically if you compare this with this, we have p is equals to, what is the value of p? Value of p will be equals to minus 2, and the value of q will be cos 3x. Okay, call this is equation number 1. Okay, now we have to find next the integrating factor. Okay, isn't it? So we have integrating factor. So integrating factor will be, so all of you know integrating factor is calculated using this particular formula, isn't it? So we have in e to the power p is minus 2, so that minus 2 can be kept outside integral sign. So we have only integral dx. So how much is this? It is integral e to the power minus 2 integral dx is x, right? So my integrating factor is this much. Now the next step is to multiply equation 1 by the integrating factor. Okay, so multiplying 1 by integrating factor, so IF stands for integrating factor. So we get e to the power minus 2x dy by dx plus minus 2 e to the power minus 2x y. Okay, so it becomes this much is equals to e to the power minus 2x cos 3x. Okay, now one of the variable out here, the number out here is e to the power minus 2x, and the variable out here is y. Okay, so when you differentiate this, okay, so when you differentiate this with respect to x, you're going to get this entire thing. You can check by yourself. Okay, so that's why this entire thing can be written to be this much is equals to, we have e to the power minus 2x cos 3x. Okay, now let me separate the variables. So when you separate the variables, so it becomes dy e to the power minus 2x is equals to e to the power minus 2x cos 3x dx. That's what we are going to get. Okay, so we have this much now. Now the next step is to integrate both sides, isn't it? So let's integrate both sides then. So let me erase this part for you. Okay, so integrating both sides, so we have integral, so dy e to the power minus 2x is equals to integral of e to the power minus 2x cos 3x out here, 3x dx out here. Okay, so now see this integral you have seen in integration by parts. Okay, so there in that particular chapter, if you remember, you have noted down formula for integral e to the power ax cos bx dx. Okay, so how much ever is the formula, there you can write a as -2 and b as 3. So you get your integral out there. Okay, so this is simple. This is just y e to the power minus 2x. But in order to calculate this, you have to use integration by parts, or you can use formula for this. Okay, so use the formula. At last, put the constant of integration. That will give you the general solution of this given differential equation. Okay, so you complete this sum by yourself. Okay, so you may pause the video and note down your solution till here. Let's move to next question now. So next question says we have to find the general solution of this. So first and foremost, let me find dy by dx. Okay, so if you find dy by dx from here, let me first take it out here. So you get y dx is equals to this much, right? So from here, if I ask you to find what is dy by dx, you will say that my dy by dx will be y by x plus 2y squared. So this is going to be your dy by dx. Now my question is, can you write this in this form, that is dy by dx plus py equals to q? I don't think that you will be able to write this in this form. Now if you are not able to write in this form, then there is one alternative. So what you can do is you can interchange the role of x and y. Okay, so if you interchange the role of x and y, then it becomes dx by dy plus p x equals to q. Okay, so let's see whether we will be able to write this in this form or not. Remember, if you have changed the role of x and y, here this p and q can be either constant or the function of y. That thing you need to keep in mind. Okay, so since dy by dx gives me this much, I'll be finding from here what is dx by dy. Okay, so dx by dy will be equals to x plus 2y square by y, isn't it? Now let's keep dx by dy out here only. So write this as x by y plus this becomes 2y squared by y is 2y. That's what you are going to get. Okay, so see, if I bring this out here, okay, so if you bring this out here and write in this format, you get dx by dy plus minus 1 by y x is equals to 2y. Okay, now see, I told you this p and q has to be either constant or function of y. So here this is your p and this is your q, and both of them are function of y because both of them are depending on y, isn't it? Okay, so call this as equation number 1 and say we have p equals to minus 1 by y and q is 2y. I hope this is clear to you. Alright, now if this is clear to you, then let's find integrating factor. So therefore your integrating factor will be equals to e to the power, it's e to the power integral p, we used to write dx, remember? But this time, since you have changed the role of x and y, that's why you have to write dy here. Instead of dx, you have to write dy here. Okay, so we have, see here carefully, e to the power integral p. P is minus 1 by y. So you can write minus outside. So you can write this as dy by y. Okay, so how much is this? This is minus log e to the power minus log y. And all of you know that this can be written as e to the power log 1 by y. And in turn, this can be written as 1 by y. Okay, so let me erase this part. So that's why, see here, I got my integrating factor, so I need to multiply 1 by integrating factor. So multiplying 1 by integrating factor. So what do we get? Let's see. So when you multiply by 1 by y, you get 1 by y dx by dy plus minus 1 by y square x is equals to, so you have 2y, so you are going to get just 2 out here. Okay, so from here, see here very carefully, so here we have the variable is 1 by y, okay, and the other variable out here is x. Okay, so just multiply with x and let's differentiate this with respect to, earlier remember we used to differentiate with respect to x, but this time since you have changed the role of x and y, you have to write dy out here. Now kindly do this differentiation and check whether you get this much or not. So this is equals to 2. Okay, so bring this dy out here, so you get d of, this is 1 by y into x is x by y, so this is equals to 2 times dy. Now integrate both sides. Okay, so integrating both sides, so when you integrate on both sides, you get integral d of x by y is equals to 2 times integral dy. Okay, so all of you know it is x by y, this is equals to 2 dy, integral dy is just y. Now put the constant of integration. Okay, so from here you get x equals to, do the cross multiplication, you get 2y square plus cy. So this is the required general solution. Okay, so you may pause the video and note down your solution. Okay, so again as usual, I'm going to give you this as your homework, so kindly try this by yourself. I'll do one more sum for you. Okay, so the next sum for you is this one. So here what am I going to do is, I'll just do the cross multiplication here. Okay, so first and foremost find what is dy by dx. Always find dy by dx. If you are not able to change that dy by dx in the linear form, then go for dx by dy. So from here, so if you take dy here and dx down there, so you get dy by dx is equals to e to the power minus 2 root x by root x minus y by root x. So I see that I'll be able to reduce this in the general form. Okay, so we have dy by dx plus, you must have py, isn't it? So bring this out here, you can write this as this much. Okay, and this is here in the right hand side. Okay, so all this is equation number 1. So we have, what will be my p? P will be 1 by root x, and my q is going to be e to the power minus 2 root x by root x. Okay, now next step is to find the integrating factor, isn't it? So therefore integrating factor, so your integrating factor will be e to the power integral p dx, right? So p is 1 by root x dx. Okay, so can I write this as e to the power x to the power minus half dx? Can I write this? Obviously, right? So let's see in the rough what is integral x to the power minus half dx. Okay, so it's gonna be x to the power minus half plus 1 by minus half plus 1, which is, so this is x to the power half, this is x to the power half, which is square root. Okay, and this becomes in the denominator half, so when it comes up it becomes 2. Okay, so that's why this integral turns out to be e to the power 2 root x. Okay, so you can do this part in the rough. So let me erase this rough part. I hope this is clear to you. So I got my integrating factor as well. So let's multiply 1. So multiplying 1 by integrating factor, so you get e to the power 2 root x dy by dx plus you get e to the power 2 root x by root x into y is equal to, you have, see, e to the power 2 root x plus e to the power 2 root x. See here, e to the power 2 root x into e to the power 2 root x. So when you multiply these two, it becomes e to the power minus 2 root x plus e to the power not e to the power 2x, it's 2 root x, right? So you have to add the powers when you multiply, isn't it? So how much is this? E to the power 0, which is 1, isn't it? So basically when you multiply this with this, the numerator becomes 1 and in the denominator you have 1 by root x. Okay, so in the denominator you have just root x. So that's why when you multiply with e to the power 2 root x, this becomes 1 and in the denominator we are going to have root x. Okay, so let me erase this. So as usual we have from here, okay, so the variable out here is y and another variable out here is e to the power 2 root x. Okay, so when you differentiate this with respect to x, you're going to get this much only. Kindly verify. So you have this much, or you can write this as, okay, so you can write this as x to the power minus half, isn't it? You can write this as x to the power minus half. So bring this dx out there, so you get dy e to the power 2 root x. This is x to the power minus half dx. This dx comes out here, so integrating both sides, okay, so you have integral d of y e to the power 2 root x is equals to integral x to the power minus half dx. Okay, so all of you know this is y e to the power 2 root x, and I showed you that this integral will be 2 root x, isn't it? Okay, so since you are done with the integration part, you'll put a constant of integration. So this is the general solution of the given differential equation. Okay, so with this we close our general solution, finding the general solution of linear differential equation. Okay, and in the next class we'll be learning how to find the particular solution of linear differential equation. Okay, so with this we close for the day. Thank you very much.